The night sky is never truly dark. If you removed light pollution, the moon, stars, and galaxies, there would still be a very faint, colourful glow. That's air glow. With cameras, you can photograph it only on the darkest of nights. It's about 1/10 as bright as the combined light of all the stars. From above, it forms a luminous bubble encapsulating Earth. Appearing right at the interface to space, airglow holds clues to how our atmosphere affects weather in space, and how space weather affects humans on Earth. The bands of light span from 50 to 400 miles above Earth's surface. In the uppermost boundary of the atmosphere is the ionosphere. This is where our GPS signals and astronauts travel. What makes this region complicated is that it's constantly changing. It reacts to both energy emanating from the sun and weather near Earth's surface. And as the ionosphere fluctuates, so can conditions in near-Earth space where the space station lies. But spotting changes in the ionosphere is a lot like trying to watch the wind. You need a marker of some kind to see the invisible particles move past. And for that, we have airglow. These colourful lights reflect changes in the ionosphere, and this is due to the way it's formed. Our atmosphere consists mainly of nitrogen and oxygen, and small traces of other molecules. When these molecules reach the upper atmosphere, they're at the mercy of the sun. Ultraviolet radiation from sunlight excites them. They become energized and need to release that extra energy in some way. Atoms that remain energized long enough can emit that extra energy through light. In the lower atmosphere, we don't see as much light. The atmosphere there is dense. So when an atom becomes energized, there's a high chance it will bump into another atom and lose energy in that collision instead of emitting light. But as you travel further up, the atmosphere thins out. And like a game of dodgeball, the longer atoms stay untouched, the more time they have to emit a bright, colourful photon for us to see. That's why airglow is only seen in the upper atmosphere. But it can get even more complicated. Some collisions can produce light too. On the night side of Earth, green light is the brightest and occurs when oxygen atoms become excited through collisions with oxygen molecules. A variety of other complex reactions create red and blue light, as well as UV and infrared light that are invisible to the human eye. Each type of airglow contains information about the composition, temperature, and density of the upper atmosphere, all of which are key factors that can change dramatically and rapidly. So airglow turns out to be a fantastic proxy, illustrating not only how particles move through the ionosphere, but what kinds of particles even exist there, which is key information for helping us tease out how space and Earth's weather interconnect. And that's a great reason for NASA to study this beautiful phenomenon.